Alright, let's start with Unit 1 on the ICP Final Study Guide for Semester 2, which is Chemistry. Starting off with Question 1 of Unit 1, draw and label 3 diagrams of the particles in a solid, liquid, and gas. So let's go ahead and pull out my classic red marker. Alright, so it wants 3 diagrams of a solid, liquid, and gas. So taking a look at this in detail, a solid is going to be more packed together within the molecules itself. So what I mean by that is your solid is going to be, let's go ahead and kind of draw like a box here, kind of to show. And if we have molecules inside, our solid molecules are going to be very packed together like that. Horrible circles, but you do understand the point. Solids are going to have the least movement among molecules, and it's going to be very tightly packed in the whatever area it has. However, let's label this actually solid. Alright, horrible L. What is wrong with my spelling today? Solid. Okay. Now for our liquid and gas. Liquids are going to be more free forms. They're going to be kind of, less clumped, it's kind of moving. It doesn't have a definite shape. So it's going to be less packed, and that is going to be liquid. And finally for gas, they're going to have not a defined volume nor shape. So they're going to be just floating, doing whatever they want. Some might be a little more distanced, others may not be. That's gas. Let's try to make them as equal size as possible so it doesn't confuse anyone. There you go. So no distinct, formation you would call. All right, let's define some stuff. Let's define an element. All right, what if someone asks you on a test, right, what is an element? What would you say? Well, an element is a substance that is made of only one type of atom, and they're found on the periodic table. So let's summarize that. An element is a substance made only with one atom. And then we're going to put in periodic table. So if you see it on the periodic table and it's only one element of the periodic table, that is what or one atom from the periodic table, that is what you would call an element. So then what's a compound? A compound is a substance made from a combination of various elements in a fixed ratio. That's very important, fixed ratio. So let's go and summarize that. We're going to say substance with 2+ elements in a fixed ratio. All right. So one example is NaCl. That's sodium chloride. It's your table salt. You have sodium, which is a single element, and chlorine, which is another single element, in a 1-to-1 ratio. They're never 2-to-1, 2-to-3, 1-to-3. It's always 1-to-1, a fixed ratio. That's what it means when it mentions fixed ratio. All right, what's a homogeneous mixture, right? An easy way to remember this is the difference between homo and hetero. And we'll talk more about this in a bit. But homogeneous mixture is a mixture where the components, the substances inside, are uniformly distributed and inseparable from one another microscopically without you can't see the substances. So let's try and summarize that. Let's say a mixture with compounds uniform, distribute, that's horrible spelling on my part, hold up, a mixture with compounds uniformly distributed and indistinguishable is the word I was looking for. Indistinguishable. So you can't tell the two substances in the mixture apart from each other. They look like one complete thing that you can't visibly see is separated. Indistinguishable from one another. One another. Quite wordy. Sorry about that. So then what's a heterogeneous? I never know how to say that. Mixture, right? If homo means the same and it's indistinguishable, hetero means different and therefore is distinguishable. So this would be a mixture. Let's see if I can fit it all here. Mixture where the compounds or substances where compounds are not uniformly distributed and are wholly distributed and visibly, you can see it, visibly distinguishable. So you can see the differences between the one substance in the mixture and another in the same mixture. So homo means the same and hetero means different. Okay, how does a compound differ from a heterogeneous mixture, or homogeneous mixture, sorry? So what is a compound, right? A compound we talked about was a substance of two or more different atoms in fixed proportions, right? And in order to separate these, you have to have a chemical process that a compound goes through. And for homogeneous mixture, you do not need to use a chemical way of separating because they are not bonded chemically. Compounds are bonded chemically using ionic covalent bonding of different elements in a fixed ratio. But for homogeneous mixtures, they are not chemically bonded, meaning they're not ionically or covalently bonded. They're just mixed together really, really, really well. But they're not mixed well enough that it's not chemically bonded. So let's write this out and hopefully it makes more sense. So a compound is chemically bonded and therefore needs separation chemically. However, let's write this in blue. A homogeneous mixture is not chemically bonded, and you can separate it without a chemical method of separation. So you do not need chemical. I ran out of space there. Chemical separation. All right, and that is basically the difference between a compound and homogeneous mixture. All right, scrolling down a little bit, let's classify. It says classify the following types of matter as an element, compound, homogeneous, or heterogeneous mixture. How they broken down by physical or chemical changes. So let's take a look here. Water is H2O, right? And you have more than one atom or element bonded together in a fixed ratio, 2:1. So H2O, 2:1 fixed ratio. And you're going to be creating a molecule of a combination of a fixed ratio, and that's a compound. So water is a compound, and it can be separated because it is a compound by chemical changes. And this process of breaking down water is called electron. I'm actually not going to write that down. It's broken down by a chemical method of change called electrolysis into its respective hydrogens and oxygens. But water itself is a compound because it's made up of more than one element in a fixed ratio. Well, let's talk about salt water, right? If you've ever put salt, just table salt in your water, right? And you mix it in real well, and it starts to look like it's just one mixture, right? But if you boil it off or let the water evaporate, you're just going to eventually be left with the salt crystallized back in the water. And that gives a sign that it's a mixture because it's not chemically bonded, so it doesn't need a chemical method of separation. By leaving it out, and that's a physical change, right? Leaving it out, evaporating with high temperatures, you can separate the water and salt. And so because of this, salt water is a homogeneous mixture, which undergoes a physical change to break down, right? A physical change meaning evaporation, boiling, and stuff like that. Next, let's talk about copper. Copper has the symbol Cu and is found on the periodic table. Nothing else, nothing less. Just copper is going to be an element. It's a single atom that is found on the periodic table, which makes it an element. And because it's an element, you can use, because it's copper and it's a metal, you can use a physical change to, alter it. But it still, remains copper. You can't, just because you change the physical aspect of copper, it doesn't mean you're no longer copper. You're going to be still copper, just in a different form. So this undergoes physical change to break down. Well, quote, break down, but it'll require a physical change to alter into a different form is the word I'm looking for. And so for the last one, we have dirt. Dirt is a heterogeneous mixture. Let me explain why. Heterogeneous. I cannot spell. Mixture. And this is a heterogeneous mixture because if you go grab a handful of dirt outside, you're going to have different sized rocks, you're going to have pebbles, you're going to have maybe like worms or ants in it if you're lucky, right? And you're going to have the soil, and you can see the various aspects of dirt, right? You can see the small pebbles, you can see the big rocks, you can see the soil itself, and you can pick those out, and therefore it's a heterogeneous mixture, because the definition of a heterogeneous mixture is a mixture where its substances are not uniformly distributed and are distinguishable using visual methods. You can see the different substances making it up. And so because of that, the only way to break it down is going to be physical. So physical change. All right, question 5. Identify the following changes as physical or chemical changes. Right. So if you melt something, let's consider water and ice. If you melt ice and it becomes water, you can't change the identity. It's still water. Therefore, A is going to be physical. Okay, let's take a look at B. B is the production of light and heat, right? Which is a very telltale sign that a chemical change has occurred. If you're producing heat, that means something has reacted with one another to make heat. One example is if you burn a piece of paper and it creates heat, right? That's a chemical change. That's combustion that just occurred there. Same thing with light. If you burn something, it produces light. That is another sign of chemical change. Therefore, B is, that's a horrible C, that's a chemical. Let's take a look at C. Unexpected color change. That's the key thing about this. Unexpected. If you don't expect something to happen and it suddenly changes color, right? If it changes from clear to kind of black or red or orange, it's going to be a sign of a chemical change. You weren't expecting this to happen. Next up, let's consider rusting. Rusting, it may seem physical because you're just adding a layer of rust on iron, but it's actually chemical. Let's take a look why. Rusting occurs when oxygen reacts with metal, like iron. And so when iron rusts, it's a chemical reaction of Fe, iron plus oxygen O2, creating a compound called FeO2, right? That's iron oxide. And so that is why it's a chemical change. It may seem confusing at first, but if you go on with your studies with chemistry, it'll make much more sense. But for the purposes of ICP, I would just personally memorize that rusting is a type of chemical change. Next up for E, decreasing mass. If you decrease the mass of a compound, you cannot change the identity. You can't, just because if you say, okay, let's give an example. If you have 100 grams of magnesium metal and you cut off 50 grams of it, just because you have 50 less grams of magnesium doesn't mean it's not magnesium. It's still magnesium. It's just you have less of it. Therefore, it's physical. And then finally for F, if you change the shape of something, same thing with question or part E, physical, right? If you change the shape of something and make it a different shape, you don't change the chemical identity of it. If you bend a copper rod into a wire, right? You're still copper, it's just in a different shape. Therefore, it's physical. And I hope you noticed a pattern within these, because if it's a physical change, it will not alter the identity of the substance. If it's a chemical change, it will change the identity of what it was before. And so that's an easy way to identify if a change is physical or chemical. All right, moving on to our last question, 6. Identify the following properties as physical or chemical. Right, start with A. Reacts with an acid. If a substance reacts with an acid, it can change the chemical identity. Therefore, it is a chemical property. And taking a look at B, B is melting point. Melting point is, in fact, a physical property. Because no matter how small or large of an amount of a substance you have, regardless of what it is, the melting point will not change. Just because you have 1 gram versus 100 grams of metal, the melting point will not change. It will be identical because that's part of its identity. So therefore, this one will be physical. Let's take a look at C. Shiny. That's probably for metals. Not always, but most of the time. If a metal is shiny, and if you make it not shiny, that doesn't mean that it's still not that metal. Just because your stainless steel knife is less shinier than before, doesn't mean that it's not stainless steel. It's just stainless steel, but less shiny. Therefore, it's physical. Let's take a look at D. D is temperature, right? Temperature is also a physical property. This is a great example with ice. Just because ice and water are different temperatures, right? If water's temperature goes down enough, it freezes and turns into ice. Just because it has a less temperature doesn't mean it's not water. It's just frozen water. It's just a different type of water, right? A different matter, like a state of matter, which we'll go over, of course, in Unit 2, but we're getting ahead of ourselves. So temperature is a physical property. Mass. Mass is also physical. Just because you have less of something doesn't mean you change its identity, what we've been reinforcing within the past 2 questions. Lastly, density. A lot of people get this wrong. Trust me, just if you don't understand, let's try to make it clear here. Density is a physical property because it's a distinctive property that a substance holds that remains unchanged regardless of how much you have, right? If you remember the formula we went over in Unit 0, right? Density is mass over volume. Just because you change the amount of it you have doesn't mean it changes how dense it is, right? If you have a block of metal and it's, say, has a density of 15, right? Just because you cut away a small little marble or cube with it doesn't mean it gets less dense. It's still the same density, just in a smaller amount, right? The property remains the same, although the size may decrease or increase. It's still a property that that specific substance holds. Therefore, density is physical. All right. That's the end of Unit 1. I hope this helped. We'll see you in Unit 2 with states of matter and gas laws. Thanks.